What I'd like you to do is to turn to this page in your lab handout. On this page in the lab handout, we have two examples of soil profiles sketched in. What I'm going to have you do is, as I go through, I'll go through and talk about each of these two soil profiles. I will point out and measure the depth at which they occur in the profile. I would like you to sketch those in, and then based upon what you see as being differences and causes for those differences within the two profiles or monoliths that we cover here today, identify those zones or transitional zones within the soil, and write a brief description beside each of those as to what you see as being the major horizons, subhorizons, or transitional horizons within these two soil profiles. Also, upon completion of that, there are 6 review questions that are associated with this lab that I'd also like to have you complete. And upon completion of these two exercises, then you would send these materials back into me for evaluation. So with that, what we'll do next is to look at, first of all, the Palouse series soil. Now, Palouse series soils are found in many areas of eastern Washington. Indicative of these soils, they're typically found in areas of rainfall at 18 inches up to a maximum of about 25 or 26 inches. They are very rich, they're very productive soils, and most of them are being used for dryland agriculture, production of wheat, peas, and other dryland rotational crops. On the top diagram on your lab handout, I would like to have you sketch in what you see as being the major horizons and or subhorizons in the Palouse series soil. To help you or assist you with this task, I'm going to go through and take some measurements to show you at what depth I believe these horizons and or subhorizons to begin and end. If we look at this soil profile in perspective initially, what we see and what we'd expect to see is a much darker soil near the surface due to the accumulation of organic materials. And then as we progress down in the profile, we see a lightening. Now that lightening of color is due to less organic matter, but it can also be due to different degrees of oxidation or states of oxidation of the minerals in the soil. As I look at the very top of the Palouse profile, I see a zone here that's approximately 10 centimeters in length. This zone is an area that is dominated by a very high accumulation of organic material. Now, I will tell you that we do not have an O horizon in this soil profile. O horizons, as I mentioned earlier, are more typical of the perennial forest type of vegetation. Here, this soil was formed and developed under grassland vegetation. I will also tell you that this soil has never been cultivated, so we do not have a plow or cultivation zone here. So there is something causing this top 10 centimeters approximately of the soil to be a little bit different in appearance than this zone that begins here and proceeds down to a depth of approximately here. So we have 10 centimeters in this first zone. The next zone is approximately 20 centimeters in depth, so it extends from this portion of the profile to this portion of the profile, depth of approximately 20 additional centimeters. We begin to see a change in coloration here. We've got some organic matter that has been alluviated down in the profile, but we also start to see the glaying or the color coming up from the more brightly colored yellow and reddish clays from below. So we have this transitional zone occurring that runs from approximately here down to a depth of here. Okay, that depth, or that section of the profile, would be approximately 25 centimeters in length. So we have a 10 centimeter zone, a 20 centimeter zone, and then another 25 centimeter zone that's a transitional horizon. When we get below that, we see a much lighter color in the soil profile. We don't see the darkening. We see a maximum zone of clay accumulation here that has been alluviated from the soil above. This zone runs from approximately this point in the profile to this point in the profile. And that would be a depth of an additional 22 centimeters. Below that, We don't see quite the yellowing or brightness of color that we had in the zone immediately above. This zone is a zone of maximum clay accumulation. This zone has quite a lot of clay in it, but also being a part of the subsoil, it does not have extra clay in it that has been alluviated from above. So the alluviation zone is here, and below that we have a much more typical portion of the B horizon. So with that information, I would like you to sketch this one in on your example sheet in your lab handout. Sketch those zones in as I've described them and tell me what you believe each of these horizons and or transitional or subhorizons to be. Also, beside where you write that designation with the letters, I would like you to write in a description of what you see being the difference between, for example, this zone and the zone immediately below it. So as you go from one zone to the next as I've described them, tell me in writing what you believe the difference to be between and what's caused that difference to occur between each of these zones. We'll move next to the Ritzville series soil.